Good afternoon, guys. So we are going to continue talking about probability today. So yesterday, the activity that you did with simple probability was all things that you should have done back probably honestly in middle school, definitely in Algebra 2 if not. But it was just basically writing one fraction or one decimal to represent the probability that something happened. What we're looking at today is called compound probability, which means how do I find the probability when two or more things are happening? So, for example, if you're thinking about your deck of cards, what's the probability I draw a red card and then a black card right after that? Okay, something like that. So the first rule that I want to introduce to you is the addition rule, and this deals with questions that say this or that. Okay, we've talked a lot this year about the difference between or and. If there is a question, okay, that asks you, what's the probability that I get this or that? That means both things don't have to happen. Only one of them does. Well, in that situation, what I do is I add the probabilities together. That's what P of A plus P of B means. This last little part right here, where it says minus P of A and B, we'll talk about that a little bit more here in just a minute. But what that's referring to is if you have something that falls in both categories, A and B, don't count it twice. That's what it's talking about. So let's go ahead and get started on this. So for example 1, says if a single card is drawn from a standard 52 card deck, what's the probability that it will be a spade or a red card? Well, I see the word or there. That means I have two separate probabilities. They don't both have to happen. Only one of them has to happen. But to get the probability that one or the other happens, I add them together. So I say, okay, what's the probability that I get a spade? Well, there are 4 spades in a deck, and there are 52 total cards. What's the probability that I get a red card now? Well, half the deck is red, so that's 26 of them out of 52. Well, when I get that, when I add those together, 4 plus 26 is 30 out of 52. So if I read this probability logically, what I'm saying is I want any of those 30 cards out of 52 that happen to be a spade or happen to be red. And that one will actually reduce down to 15 out of 26. And you can definitely reduce that down to a decimal if you would like to, but you don't have to. Hey, let's say I look at example 2. Example 2 says this. There's a lady here, Amy Hogan. She plans to spend from 1 to 6 hours on her homework. Maybe she's in grad school like me. So X is going to represent the number of hours that she could possibly spend this week on homework. P of X here tells you the probability that she spends that number of hours. So there's a 5% chance that she only spends 1 hour on homework this week. There's a 10% chance that she only spends 2 hours on homework this week. Okay, and it goes on down the line. Part A asks you this. What's the probability, so that's what that P stands for, what's the probability that she spends fewer than 3 hours on homework? Well, which options are fewer than 3? Well, 1 and 2. So I want you to read this question in a different way. Instead of saying, what's the probability she spends fewer than 3 hours, I could say, what's the probability that she spends 1 hour or 2 hours on homework? Well, in that scenario, when I have the word or, what do I do with my probabilities? Well, I add them together. The probability that she spends 1 hour is 0.05. The probability that she spends 2 hours is 0.1. When I get those together, she has a 15% chance of spending fewer than 3 hours on homework this week. Okay? Now let's look at option B here. And option B actually includes kind of 2 statements here. It says, what's the probability she spends more than 1 hour, but no more than no more than, I left out the number there, that's supposed to be a 5 there. So what's the probability she spends more than 1 hour, but no more than 5? So think about it this way. More than 1 would be everything from 2 all the way over. But if it's no more than 5, that takes out 6. So what we're actually saying here is, what's the probability she spends 2 or 3 or 4 or 5 hours on homework? So all I have to do is add together the probabilities that go with those numbers. So 0.10 plus 0.20 plus 0.40 plus 0.10. And when I add all of those together, I get 0.80. So there's an 80% chance that she spends somewhere between 2 and 5 hours on homework. Okay? All right, last one here is a little bit different, and this kind of brings in that piece that I mentioned at the very beginning about sometimes we have to subtract something out. Okay, and here's what I mean by that. It says find the probability that a single card drawn from a 52 card deck will be a diamond or a face card. So start with this. How many diamonds are in a deck? Well, there's 13. So the probability that I draw a diamond is 13 out of 52. I see the word or, so I know I'm adding. It says, or I could get a face card. Well, how many face cards are there in a deck? Well, there's a king, jack, and queen for each of the 4 suits. So total, there's 12 face cards. But here's the problem. I already counted 3 of those face cards when I counted all the diamonds, because 3 of the diamonds are face cards. I don't want to count those 3 cards as diamonds and as face cards. So what do? Well, I subtract out 3 of them. What I did is I made sure I didn't count those 3 cards that were diamonds and face cards twice. Okay? Well, when I put this all together, 13 plus 12 is 25. 25 minus 3 is 22. So 22 over 52 reduces down to 11 over 26. So there's how I deal with probability if I have the word or. If you have probabilities that deal with the word and, it's kind of a different idea. And probability is the idea of intersection. Where do things overlap? And you'll see that here a little bit more in just a minute. But if we say the word and, I ate a cookie and a brownie, that means I ate both of them, not just one. Well, what do I do in that scenario? Well, I take my 2 probabilities and I multiply them together. Okay, so example 4, we'll start out with a table. And I think you'll see why we use the word intersection when we talk about probabilities involving and. So it says, using the table below, find the probability that you randomly select a hardcover fiction book. So another way that I could read that is find the probability that you randomly select a book that is both hardcover and fiction. Well, what I would do in that scenario is I would find the place on the table, okay, the little cell right here, where the hardcover row intersects the fiction column. How many books fall in that space right there? Well, 3. So 3 out of 20 of those books are both hardcover and fiction. So that's why we use the word intersection when we refer to the word and when we're dealing with probabilities. It's where a row on the table intersects a column. Okay? Well, if they don't give me a table and I can't just look at it and tell what the answer is, look at what I do. It says find the probability of drawing a diamond from the deck. So we'll start there. How many diamonds are in the deck? Well, 13. So I have a 13 out of 52 chance of drawing a diamond. But then I'm going to put that diamond back after I draw it. So I still got 52 cards in the deck. And now I want to draw a 2 from the deck. Well, how many total 2s are in the deck? Well, there's 4. So I am now multiplying, because it said and, 13 over 52 times 4 over 52. And I can do that in Desmos. Okay, and I'll change that to a fraction. As a fraction, that is 1 over 52. And in case you didn't catch that, in Desmos, if you want to change something to a fraction, it's this little fraction symbol right up here in the left-hand corner of the bar that you type in. Okay, so there's the probability that I do one thing and then something else. Example 6 here has one little extra phrase that we'll talk about. It says, find the probability of drawing 2 aces in a row, which means I get 1 ace and then I get another one. Those both have to happen. Okay? What's the probability that I draw an ace the first time? Well, there's 4 of them, so 4 out of 52. But look at what happens here. There's a key phrase here. Find the probability of drawing 2 aces in a row without replacement. What that without replacement means is once you draw the first ace out of the deck, you don't put it back. So look at my second fraction here. I started with 4 aces and 52 cards, but once I draw one out, there's now only 3 left in the deck, and there's only 51 total cards. So notice how this is different from example 5. Example 5 says when I pulled that first card out, I put it right back, so there were still 52 cards in the deck. Example 6 says I don't do that. It's just like in a card game. When I draw an ace out, I want to keep it. So now there's only 51 cards in the deck, and there's only 3 aces left. So I go over to Desmos. I say, what is 4 over 52 times 3 over 51? And as a fraction, that is 1 over 221. So think about that, guys. If you were to draw 221 times out of a deck, you would only expect to get 2 aces back to back one time. So your odds of that happening are very, very slim. That's why aces are so valuable, okay, when you're playing card games. All right, so there are your notes for compound probability. This should get you through your assignment for today, but please let me know if you have questions.